All right, let's go ahead and get that link. Should be on my YouTube. So if you don't know what my YouTube channel is, it's youtube.com/@theshyhat. And I'll just leave that down in the chat for everybody to see. We've got all of our previous live streams over there if you want to take a look at any of the previous ones. And let's go ahead and get the link for today's live stream as well. So there you go. All right. So we're going to be continuing on with our digital forensics course, and let's go ahead and start the lesson. All right, everybody, this is Hacker Frogs After School. This is Disk Image Forensics Part 1. So we've been doing our digital forensics class, and we've got about three more classes for this particular topic after this, and this is the 5th session. So what are we going to be talking about today? This is the 5th class for digital forensics, and in the last workshop, we learned about the following digital forensics concepts. We learned about Wireshark. So Wireshark is a program which is widely used for network traffic analysis, and we use it to analyze PCAP files. Remember that PCAP files are a bundle of different packets all put together, and they symbolize all the traffic, the internet traffic that's going on across a specific computer network. So we learned a little bit about exporting files from Wireshark, so we could get any file that was captured inside of the PCAP file, and we could download it. And what else did we learn? We learned that we could use a bunch of different filters in the Wireshark program in order to isolate very, very specific types of packets. And this helps us get some information from what exactly is going on the network. And we also learned about searching for strings in packet contents. So even if we don't necessarily know which packet we need to look at first, if we know that we're looking for a packet with a specific word inside of it, we could search for that word and then try to get Wireshark to return only the packets that have that word in them. Okay, so that was what we learned last time. What are we learning this time? So in this workshop, we're going to be going over the following 4 things. We're going to be talking about disk image forensics. So what is this disk image forensics thing? And then we're going to be solving some challenges over at PicoCTF. So we're going to be solving the SleuthKit Intro Challenge, the SleuthKit Apprentice Challenge, and the Operation Orchid Challenge. So let's go ahead and talk a little bit about what is digital disk forensics. So when we talk about digital disk forensics, we basically mean taking a look at the contents of hard drives or storage drives, really. Digital disk forensics is the examination and analysis of information stored on digital disks, such as hard drives, USB drives, or any other type of storage media. So a lot of people use phones these days. You can also do digital disk forensics on phone contents as well. So disk forensics is often used in cybersecurity incident response to analyze and identify devices that may have been compromised in security incidents. So if for some reason there was a security incident where a person's device was infected with viruses or malware, we could potentially use digital disk forensics to inspect those devices and see what the heck is going on. Okay, so we're going to be using a very specific type of software to do these digital disk forensics exercises. And the software we're going to be using is called the SleuthKit. The SleuthKit is a popular program used in digital disk forensics, and we can access it from the PicoCTF web shell. So let's go ahead and activate the PicoCTF web shell. So what I want you to do is I want you to log into PicoCTF. So if you haven't already logged into PicoCTF, you can do it from this link over here. And if you don't have an account over at PicoCTF, you can make one and then log in. So after you've logged into PicoCTF, you want to open up your web shell. The web shell is basically a Linux computer that you can use to solve PicoCTF challenges, and I'll show you how to access it. So after you've logged into PicoCTF, you need to click on the practice button over here. It's going to be one of the top buttons when you arrive at the page. You click on the practice button, and then you scroll down a little bit in the page, and you're going to see that there's going to be a web shell button over here on the right-hand side of the interface. So you want to go ahead and click on that button, and that's going to open up the picoctf web shell in its small form. So we don't want the small form of the picoctf web shell, we want the big version of the web shell. So what we can do is we can go to the picoctf web shell and then move our mouse over to the right-hand side, and to the right of the help button is this button right over here. It's labeled Pop-out Web Shell Terminal. It looks like a box with an arrow pointing out. You want to click on it, and then after that, you're going to see the Web Shell Terminal in its large form. It's going to be in its own separate browser tab. So if you manage to open up the web shell in its big form, let us know in the chat by typing in the web shell is big, just like this. Okay, I see Venting Horse has the web shell big. That's great. And user 3 also has a big web shell. Great. Okay. All right, let's go ahead and start then. So if for some reason your web shell doesn't start up, you can go ahead and do the process over again, and that eventually you'll be able to open it up. Sometimes the web server over at picoctf is not very responsive, and sometimes you have to do things maybe 2 or 3 times before you can get it to work. But just keep on trying until it works. Okay, so now that we're at the web shell, we can go ahead and clear off our terminal with the clear command. And then we use ls to take a look at what's inside. It looks like I've got some old files in here. So I'm just going to clear them out with the rm command. So it's rm and then space and the name of the file. We want to keep our picoctf web shell nice and tidy, and we don't want any clutter in here, so that we've got a nice and clean interface. Okay, so let's go ahead and go back to the presentation here. So we're talking about the SleuthKit software, and we're going to be learning some basic operations of the SleuthKit in this workshop to learn about digital disk forensics. So let's get acquainted with the SleuthKit with this picoctf challenge over here. So this is going to be the SleuthKit intro challenge. I'll leave the link in the chat. Oh, okay, hold on. For some reason it cut off. Use the link that's at the bottom. Use the link that's at the bottom. Okay, so let's go ahead and go over to that link. Okay, so what is this challenge? Let's take a look at the details of the challenge before we start. So over here it says SleuthKit Intro. This is the medium level challenge in the forensics category from the picoctf 2022 event. The description of the challenge says, download the disk image and use MMLS on it to find the size of the Linux partition. Connect to the remote checker service to check your answer and get the flag. So it says, note, if you're using the web shell, download and extract the disk image into the temp directory and not your home directory. And then they've got a link to the disk image that we need to access for this challenge. So what I want you to do is I want you to hover over the download disk image link over here, right click, and then select copy link. After you do that, you want to go over to your web shell, and sometimes you're going to see that the web shell is going to disconnect you. It's going to disconnect you if you don't type in the web shell after a few minutes. So you just need to click back into the web shell and hit the enter key to reconnect to the web shell. Okay, so this is what we need to do first. So we need to create a little directory for ourselves inside the temp directory. So the temporary directory is for temporary files. And the reason why this challenge doesn't let us copy the file into our home directory here is because the file is too big. So what we're going to do is we're going to create a directory for us to work inside of. So what I want you to do is I want you to use this command. So mkdir for make directory, then space, and then /tmp/ for something in the temporary directory. And then I want you to type in your username. So for example, my new username is the Shy Hat. Your username is probably something else. You want to type in that username. You don't type in my username, you type in your own username. And then underscore, and then, oh, what are we going to name this? We're going to name this SK for SleuthKit and SK1. So your name underscore SK1. And then hit enter. And then you want to enter that directory by doing the cd command. So it's going to be cd space /tmp/ your name underscore SK1. Okay, and after you do that, hit enter. And when you type the pwd command to get the working directory, print working directory, it's going to say /tmp and then your name underscore SK1. So if you type pwd and then you get this result over here, your name underscore SK1, please let us know in the chat by typing in SK1 smiley face. And as usual, if you're having troubles, let us know in the chat and we'll try to answer, we'll try to address your problems as best we can. So the command is going to be mkdir space /tmp/ your name, and you don't necessarily need to type your name like this. It's going to be your name over here, and then SK1 like this. After that, you want to use cd to enter that directory. And then when you type the pwd command, it should give you this output over here, /tmp/ your name underscore SK1. So one more time, if you manage to create that directory and then enter the directory, and when you type pwd, it says this, let us know in the chat by typing in SK1 smiley face. Okay. User 3 has got it done. Any other users, if you're having trouble, let us know because we'll try to help you out. Okay. So let me talk about the next step. So the next step is going to be to download the file. And one more time, we can go back to the challenge page over here, SleuthKit intro, and then we can right-click on the download disk image link and then select copy link. After that, we're going to go over back to the web shell and we're going to download the file into our SK1 directory here. So you can type wget space and then paste in. Oh, yeah, I need to get my link again. Okay, so go back here, select copy link, go back to web shell, paste in this file address here. And you know what? I'm going to copy this into the chat so everybody can do the same command. Okay, so everybody, if you're having trouble getting the command, then this is the command you can just copy and paste. There you go. And then hit enter. That should download the file. It's a pretty big file. And you're going to see the progress bar over here. When it's done, you want to give the ls command to make sure that the disk image is in here. So type ls. You should see disk.img.gz in your file, in your directory here. Okay, and if you see it, type in the chat, I downloaded the big file. Smiley face. Okay, Venting Horse says, I see it. Okay, so you, good to see, good to see. Okay, so this should be disk.img.gz. And the next thing you need to do is you need to unzip the file. So this is a zipped file. And if you want to know what the contents of a particular file are, you can just type in the file command. So file space and then the name of the file. Remember that you can start typing in the name of a file and then hit the tab key on your keyboard to autocomplete the file name. It's a very useful technique for typing in the names of long file names. Okay, so this is gzip compressed data, and it says it was disk.img. So this is a compressed file. We need to uncompress it. We need to unzip it. So the command we're going to do to unzip the file is going to be gunzip. So gunzip, I guess you could say, and then space, and then disk.img.gz, like this. So after you give this command, hit enter. It's going to take a little bit of time, but after it's done, you're going to see this file here. So disk.img.gz becomes disk.img, like this. So this is the command that we give. I'll just paste in the chat just in case anybody needs to use it. Okay, so disk.img. So this is the actual disk image file that we're going to be taking a look at. And if you type in file disk.img, it'll tell you what kind of file this is. So it tells you that this is a DOS MBR boot sector, partition 1, and this is what we want because this is a disk image file. And what we're going to do is we're going to use some tools to take a look at what's inside the file. So let's talk a little bit more about this. So the challenge is actually asking us to use the mmls command, and the mmls command is going to display the media management, or of a disk image in the list format. So it's kind of like ls in Linux, but we're doing it on the media management. So it's mmls. And what this is going to do is it's going to tell us where the disk partitions are in a particular image. So the partitions are basically the file system for a device. So an operating system like Linux or Windows is going to have several different disks, and we want to find the Linux disk on this image file. So let's go ahead and do that. So we're going to go back to our web shell, and we're just going to run this command. So it's mmls space and then disk.img. So this is going to tell us where all the disk partitions are. Give the command, and you're going to see that there are 3 different things in the table in this image over here, and we're looking for the Linux one. So this is the Linux partition over here. Remember, if we go back to the challenge, it says download the disk image and use mmls on it to find the size of the Linux partition. So can you tell me, so from this output over here, what is the size of the Linux partition? This is the Linux partition information over here. So can you guess which number is going to be the size of the Linux partition? If you know, type it in the chat. And if you just want to give a guess, that's fine too. So the answer is this number over here, the length of the partition. So length is how much size or how big a partition is. And there's also some very important information here that's talking about the partitions as well. So start over here tells you where the partition starts inside the image. So it starts at 2048 bytes inside of the partition, which means that this is called the offset. It's basically where this partition is inside the image, and it says that it ends at this particular address over here, and then it tells you how large the partition is in length over here. So the length is actually, what is this number? Length seems to be the thing that makes sense. Zos the goat herd, hello, nice to see you on YouTube. Nice to see you. Yeah, so this is going to be, is this 20,000? No, this is 200,000. So this is 200,000, 202,000, wait, 202,752. Okay, so this is the answer that we need to provide to solve the challenge, and this is how we're going to do it. We're going to go over and yeah, Zos the goat herd. Question: does it need to be changed to human readable units? I think we don't need to change it to human readable units to solve the challenge. And if you're looking for where we can access this challenge, this is the link over here. Okay, so what we need to do is we need to supply the answer in the challenge, and we need to start up our online service to do that. So go back to the challenge page, and then click on the blue Launch Instance button. So click on it, and then wait for a few moments. And then it's going to start up the virtual machine that we need to communicate with. You'll know that it's working when you see this instance time remaining, and you've got some a countdown happening here. So down a little bit, there's going to be the access checker program, and we need to copy this command. So copy the command that starts with NC and ends with this number over here. So highlight it all, and then select copy. Right-click, copy. Then go over to your web shell. In the web shell, you're going to click into the web shell and then paste in the command. So this command is going to be very similar. Your command and my command is going to be similar, except that the number is going to change. So your port number is not going to be the same as my port number. So go ahead and paste in the command and then hit enter. And then it's going to give you the answer. So sorry, it's going to ask you, what is the size of the Linux partition in the given disk image? Length in sectors. So length is the clue here, and you can just go ahead and copy this number. Copy the number, right-click copy, and then paste in the answer here. And then hit enter. And then it'll say great work, and it'll give you a flag. Okay? So if you're wondering what the number you're supposed to put in is, I'll just paste it into the chat. Okay, and this is the flag. So what we need to do is we need to copy the flag, then go over to the PicoCTF page and scroll down to the bottom. At the bottom, there's this flag submission field. Click into the flag submission field, paste in the flag, and then click on Submit Flag. Okay, and it should say, hooray, you solved this challenge. So if you manage to successfully solve the challenge, type in the chat, I did it. I did it, smiley face. So it is in sectors, answered my own question. Yeah, it turns out it was in sectors. Okay, awesome. Everybody got it done. Okay, let's move on to the next challenge. So over here, back in your web shell, you're going to press Control-C to get out of this. So Control-C is going to quit out of this program. So it's a keyboard shortcut, Control+C. So press those two buttons at the same time, and you should see this this little symbol here. So after that, what we're going to do is we're going to delete this directory. Well, we're going to delete this this image here because we don't need it anymore. So we're just going to delete it. We're going to do rm space disk.img. So go ahead and do that, and then type ls. You should see that nothing appears. Okay? After that, we're going to solve our next challenge. So let's go ahead and talk a little bit more about the commands we're going to be using for the next challenge. So we're going to be going over to this next challenge. It's called Sleuthkit Apprentice. And we're going to be learning about this Sleuthkit Apprentice challenge and more commands from Sleuthkit over here. So let me go ahead and copy this challenge over here. So this is the link I provided in the chat. Okay, let's go ahead and go there. Okay. All right, so this is the Sleuthkit Apprentice Challenge. And let's read up a little bit about this. So it's Sleuthkit Apprentice. It's a medium level challenge in the forensics category from the PicoCTF 2022 event. The description says, download this disk image and find the flag. Okay, so we've got this disk image link over here. We need to right click on the link. So download compressed disk image, right click the link, and then select copy link. After we do that, go over to the web shell, and in the web shell, when you type pwd or print working directory, you should be in the temp directory. So once you're in the temp directory, that's the right place. You can type wget space and then right click, paste in. I accidentally got rid of my link. Sorry, we're gonna go back to the challenge and then copy the link and then go back to the web shell and then paste in the link. Okay, so this is the command we're going to use. I'll just provide it to everybody in chat. Okay, so hit enter, and that's going to download the file. So the download is not going to go super fast. This should complete in about 20 seconds. So 20 seconds can seem like a long time. But you should see the loading bar over here, the progress bar, I guess, and it'll slowly fill up until it hits 100%. Okay, and then after that's done, if you type ls, you should see that the disk.flag.img.gz file is here. If you see it, let us know in the chat. Type in I see it with a smiley face. Okay, great. Thank you for using the same smiley face. Okay, so this is what we do. We need to unzip this file. So we're going to unzip it the same way we did it last time. So we're just going to give the gunzip command. So gunzip space and then disk and then hit tab to autocomplete the file name. So this is the easier way to do it. After that, hit enter. And then when it's done, type ls, and you should see the file has changed names. So it goes from disk.flag.img.gz to disk.flag.img. So this is what we want. So if we run the file command on disk.flag.img, we should see that this is a DOS MBR boot sector, partition 1. So it's got several different partitions over here. So there are a few different partitions in the image file, and this is what we want. Okay, so the next thing we're going to do is we're going to run the same command we did in the last exercise. And in the last exercise, we ran the command mmls space disk dot, well, the name of the file. So in this case, it's disk.flag.img. So go ahead and give this command. you're going to see that there are a few different partitions in here. So there's going to be primary table, unallocated, and then Linux, and then another Linux, and then a third Linux over here. So if you manage to successfully give this command, and you see this kind of output over here, let us know by typing in, I see the parts, smiley face. So I just want to make sure that everybody's on the same page. And as usual, if you're having troubles, let us know what part you're stuck at, and we'll try to help you get back on track. Okay, and we're going to learn about a new command now, okay? So a new command we're going to be using from the sleuth kit, and this is going to be the fsstat command. So fsstat stands for file system fs statistics stat. And the fsstat command is used to display statistics or stats associated with the file system, or fs. So when we run this command, it's going to give us a bunch of information about the partitions. But we also need to supply the byte offset of the disk partition with this -O over here and the name of the disk image. So this is what we're going to do to run the fsstat command. Let's go back over to the web shell. So we need to give this number over here for start for each one of these partitions. For example, 2048, or 206848, or 360448. And this is how we're going to run the command. So fsstat space, and then -O for the offset, and we're going to supply the number over here. So we're going to start with the 2048, and then space, and then the name of the file. So the name of the file is disk.flag.img. So we can just copy and paste this if we want. When we give this command, it's going to give us a bunch of information about this disk, about this partition rather. So we don't need to pay too much attention to this information, but we are going to pay attention to the stuff at the top. So at the top, it gives you file system information, and then it tells you what kind of file system it's using. In this case, it's using ext4. This is a type of Linux, a Linux file system. So it gives you the volume ID number and a bunch of information about this file system. So the only thing we really need to know is that this is using an ext4 file system, because we're going to be using this in some further commands. So let's go back down, and then let's clear. Remember, you can do up and down in your web shell to get your previous commands. So if we wanted to run this mmls command again, we can just go up and down in the history and then get that again. So what we want to do is we want to run the fsstat command again, just to make sure that these are all using the same file system, the ext4 file system. So we're going to give the fsstat command again, but this time we're going to run it with this number. So 206848. And this is going to be checking a different partition. So we just checked this one. We just checked this first one over here. We're going to check this one next. Okay, so when we give this command, it says cannot determine file system type. So we can ignore this partition here because it doesn't seem like we can read it. So we're going to read the last one instead. And the last one is number 360448. And let's go ahead and change out that number. So the number is 4360448. And when we get the information about that, let's scroll up back to the top. And we get this information here. So this is also an ext4 file system type. And while this is all the information we really need to know about this right now. Okay, so let's go back down to the bottom. We can clear the screen. And let's take a look at the next command we're going to be given. So we did the fstat command to get information. And we're going to get the FLS, we're going to do the FLS command next. So the file system ls command, this is going to get the contents of the partition. So this command is used to list out files and directory within a specified file system. And we need information that we got previously to run this. And we're going to get the we're going to give the ext4 file system with the -f here, and we're going to give the offset with the number here, and then finally we're going to specify which image that we're going to be running it on, like this -r. So let's go ahead and do some of this. Okay, go back to the web shell. So we're going to do mmls again just to get these numbers, because we need these numbers to run the commands. So we're going to run fls, then space, and then -o for the offset. We're going to check this one over here, 2048, and then space. We're going to give the file system, so -f, it's going to be ext4 space, and we're going to give the name of the image file, so -r disk.flag.img. Okay, so this is the command we're going to be using. Okay, I'll just paste it into the chat. We've got ads running on Twitch right now, so we're just going to take a little break, about a minute or so, and we're going to run an ad on YouTube as well. And in the meantime, while we're taking our break, we're going to watch some birds. So these are my favorite birds right here, and I want to show them to you while we take our little break. And they're taking a little break too. So just take we're going to take about a minute break while the ads run, and we'll be back in about 50 seconds. So we got another half minute of ads going on right now, so we're just going to be holding tight for another 20 seconds. If you have any questions about what we're doing, let us know in the chat, because it might seem a little bit confusing if you're coming into this halfway. But we're trying to take a look at some information from this disk image over here that we downloaded. Okay, let's go ahead and put the birds away, and let's continue on with the lesson. Okay, so when we give this command over here, it's going to give us some the stuff, or the contents of the file system. So we see here that there's not very much here, and this is not what we're looking for. So we're going to ignore this particular partition. So we know that there was one more partition that we needed to look at, and it's this one over here. So the offset is going to be 360448. So we're going to give the same command, except we're going to replace the number for the offset. So we're just going to copy this. We're going to bring up the old command by hitting up in our keyboard, and then we're going to replace the number. So we're just going to get rid of the previous number. We're going to paste in the new number, and we're going to give this command again. And I'll just paste in this command for this command. And okay, so when we give this command, we're going to see a lot of stuff over here. So we got a bunch of these orphan files. We've got a bunch of different files and directories, but most importantly, down near the end of the file. So this is the end of the file. It's just a bunch of these orphan files. We scroll up a little bit until here, we're going to see some interesting files. So they've got, we're looking for the flag file over here. So we got flag.txt. This is the name of the file. And we've got flag.uni.txt. So an interesting thing here is that it's going to tell you what the node number of these files are. So when we read these files, we're going to need to tell the command the node number, and the node number for this file flag.txt is 208.2082. And let's go ahead and read this file. So this is flag.txt. So okay, I'm going to tell you ahead of time, this file has been deleted. So you can tell that something is deleted because it's going to say real alloc or realloc for reallocated. It basically means that the when the file was here, whichever space that this file occupied has been reallocated because it's been deleted already. But let's try reading this file, flag.txt, and I'll show you what it looks like. Okay, so we're going to go down. Remember, the node number that we're looking at is going to be 2082. So we're just going to remember this number. I'll just paste the number into chat. Okay, we're going to go down, and we're going to use the last command we're going to be learning for sleuthkit today. And that command is the icat command. So the inode cat command, this is used to read specific files in a disk partition according to its inode number. So we need the inode number to read this. And to use the command, we need to supply the format of the disk partition, which is the -f, the offset of the disk partition, which this is the -o, and finally the name of the disk image and the inode number, which would be disk.flag.img, and then some number. So let's go ahead and do that. So back at the web shell, I'm just going to clear this off. We're going to do the icat command. Let's see, we need offset, and the offset was 360448. We need to give the file format ext4. We need to give the name of the image file, disk.flag.img, and the name of the file, the inode number is 2082. So let me try giving the command just to make sure that this is the right thing, and then I'll copy it into chat. Okay. So this is the command here. All right, so when we give the command, we actually don't get any useful output here because this file has been deleted. So the command we did to get the file list was this, and this flag over here was reallocated, which means that the file doesn't exist anymore. But there's another file over here that we could potentially read, and it looks a lot like a flag, but slightly different. So it's going to be node 2371. Okay, so let me copy that number. And let's go back down. Let's clear the screen, and let's give the same command. This is the icat command, only we're going to be using the other number. So the number is 2371, and let me paste this into chat. Okay, so when we give this command, this is the actual flag that we're supposed to be looking at. And the flag is picoctf byte surfer something something. Go ahead and copy the contents of the flag. So highlight it and then right-click copy. Then go over to your picoctf challenge, scroll down, and in the flag submission field, paste in the flag and click on submit flag. And that finishes the challenge. Okay, so if you managed to finish that challenge, please type in the chat sleuthkit done, smiley face. Okay, great. See, some people are finishing the challenge. That's great. Okay, so the other thing that we want to, so the question is why was the file called flag.uni.txt? So here's the thing. Let's go ahead and go back to the file system ls command over here, and we're going to see that in these files here, there's the flag.uni.txt, there's the flag.txt, but there's also a history file over here. So in Linux, history files give you a list of commands that were run on the file system as history. So what we're going to do is we're going to read this file to see what commands were run on the system to delete the flag and to create this new flag over here. So this node is going to be 2363. So we're just going to run the icat command with this node over here. So let's do that. Okay, so it's the same icat command that we did before, only we're going to change out the number. So the number in this case is going to be 2363. And when we give this command, when we read this file, these are all the Linux commands that were run on the file system. And so they're basically editing files, they're making a directory, they move into the directory, they create a flag.txt file, and then they do a conversion command to create a new file called flag.uni.txt. And then they copy the contents of that into they copy the contents of the flag.txt file into flag.uni.txt, and then they use the shred command. So the shred command basically makes it so that you delete a file, but you also scramble up the bytes of the file so that if you use some sort of program like the sleuth kit to try to take a look at the contents of the file, the file contents are going to be shredded up. So that's what happened. Okay, let's see if we can do one more challenge before we finish up for today, okay? So we're going to do the last challenge. Where is the last challenge? Over here. It's going to be called Operation Orchid. Okay, and let's go ahead and start the challenge. I'll leave the challenge link in the chat. Okay, so this is going to be just like the previous challenges. We're going to unzip a file, we're going to download a file, and go ahead and go over to the link, right click, and select copy link. After you do that, go over to your web shell and delete the previous challenge file over here. So it's going to be rm-disk.flag.img. After you do that, we can download the new file. So the file, we're just going to do wget space, paste in the file address, hit enter, and that's going to download the file. So let me get the command for that, and I'll paste that in the chat. Okay, so users Venting Horse and user 3, are you in a big rush today? Do you need to get to another? Need to do something else in the next 15 minutes or so? Because if you're busy, then we can finish up the class early. We can finish up the class now. But if you've got a little bit of time, okay, you're good. Then we can do this last challenge. Great. Okay. So after you've downloaded the file here, we can unzip it. So if you remember from last time, it's just going to be gunzip space disk.flag.image.gz. So just give that command, and I'll leave the command in the chat. Okay. All right. So after you do that, you should see disk.flag.img. So if you see this file in your directory, then you're ready to go. Let us know that you're ready to go by typing in ready to go in the chat. So just like the previous challenge, we're going to be using the same commands that we did in the previous challenge. So that's going to be, let's see, mmlms space, and then the name of the image is going to be disk.flag.img. Then we're going to see that there are three Linux partitions here. And just to save a little bit of time, I'm just going to tell you that the partition that we want to take a look at is the last one here. So this is the one with the offset 411648. So what we're going to do is we're just going to get our information about that. So it's fsstat space -o 411648 space disk.flag.img. And I'll just paste this into chat in case you need to use it. Okay. So give the command, and just like the previous challenge, we also see that this is an ext4 partition here. So we're going to be using this in the next commands. So the next command we use is going to be fls. So fls, and then who just followed on Twitch? Thank you very much, Moby. Mob or Moby? Let us know. Welcome to Hacker Frogs. So it's fls-f, and then it's going to be ext4. And then we're going to give the offset, and I think the offset was 411648, and then we give the name of the file. So disk.flag.img. So these are the contents here. Let me copy the command for everybody. There you go. Okay, so we see here that there's a root directory here. So we want to see the contents of the root directory, because when we do these kind of challenges, there's usually all sorts of fun goodies like flags and stuff over in the root directory. We see that the node number, oh, disconnected me. Okay. So if it disconnects us, that means that all of our information is going to be wiped out. So just a second, let me go ahead and re-download all that stuff. Let's see if my directory is probably not there anymore. So cd tmp the shy hat sk1. Nope, doesn't exist. Okay, I'll just make the directory. So just a second, everybody. I just need to re-download the file and I need to redo the thing. Okay. Whoops. We made the directory, and then we go into... Oh, I misspelled shy hat. Like this. Okay, let me download the thing. Okay, back here. Copy the link. wget. So just a second. Sometimes you'll get disconnected randomly from the web shell. It's a bit annoying, but it is what it is. Okay, so that's done. Let me unzip the thing. Okay, and what were we gonna do? We're going to do the file system ls, right? Let me go ahead and copy that command. Whoops. Okay, let me just type in the command then. So fls-fext4-o 411648 dis.flag.img. Okay. All right, so this the root directory, we want to take a look at this. So we're just going to do let's see, I think it was the icat command. Hold on, let me take a look at my notes. So everybody, if you want to get all of the information for how to solve the challenges that we did today, it's going to be over here at the GitHub page. So you can take a look over here. This is, what is it? This is the Operation Orchid challenge. Let's see. Dispartition FLS. We want to look at the root directory and note its node number, which is going to be 472. So we're going to do FLS to take a look at the root directory with this command over here. And let's go ahead and do that over at the web shell. Okay, we're going to paste in the command. So the order of the command is a little bit different over here, but the order doesn't really matter that much as long as we have all the information in there. So this is the command here. Let me just give it to everybody. Okay, so what do we have inside the directory? So there's the history file again. There is the deleted flag file over here. So remember, when we see this this message over here, realloc, that means that the file's been deleted. And we also have the flag.txt.enc flag. This is the flag file, but it's been encoded. And we need to decode this flag before we can get the contents of it. So what we're going to do is we're going to read what happened to this flag inside the history file. So the history file has this node number here. So we're going to do the icat command. So icat space, let's see, so format is ext4, and the file is disk.flag.img, and then the node number is 1875. Okay, invalid magic. Oh, I forgot to lift the offset. We need to give the -o. So -o 411648. Okay, and let me paste this command in for everybody. Cypher Enigma says, "Evening. Hello, Cypher Enigma. Nice to see you here." And yeah, we're just wrapping up our little class in just a little bit. We're learning about how to take a look at disk forensics using the SleuthKit software. Okay, so this was the history file, and we find out what happened with the flag inside these this history file here. So we made a flag, we edited the flag, and then we used the OpenSSL program over here. So this is basically a program that we can use for encryption and decryption, and we encrypted the flag using this passphrase over here, unbreakable password 12345667. So what we're going to do is we're going to get our own flag, our own encrypted flag over here, and then we're going to decrypt that flag using the OpenSSL command again. So the first thing we need to do is we need to get our own flag.txt.enc file, and we see that it's over here at this node. So the node is 1782. So we're just going to use the icat command again. So it's going to be 1782. And if you take a look at the contents of the file, we can't read this because it's been encrypted. But that's fine. What we're going to do is we're going to give the same command, but we're going to redirect it into flag.txt.enc. So we're just going to make a copy of this file here. And let me get the command for you so you can do it yourself. There you go. So when you give this command, you should see a file in your directory when you do the ls command that's called flag.txt.enc. And if you read it, it's got the same contents as it did when we used the icat command. So what are we going to do now? We're going to decode this flag, and we can do that with the OpenSSL command one more time. So the command is kind of long. I'm just going to copy it from my notes over here, and I'm going to give it to everybody in chat. So the command is going to be, let's go back to the web shell, this over here. So it's OpenSSL AES256 -D for decode and -salt for have a salt. The in file that we're going to give to OpenSSL is going to be flag.txt.enc, and the file that we want to output is going to be called flag.txt. We also give the salt that was used to create the file. It's going to be unbreakable password 1234567. So when we give this command, it's going to give us a warning over here, but that's okay. The important part is that there's now a flag.txt file in our directory, and we can read it using the cat command. So the flag is this. So picoctf haunting past. So we can highlight the contents of the flag. Remember that it starts with the P and it ends with the ending squiggly bracket over here. So copy that flag, go back to the challenge, and then paste in the flag in the submission field here. Then click on Submit Flag, and then you're done. Okay, everybody, if you managed to finish that challenge, please type in the chat, orchid, smiley face, maybe 2 smiley faces. And as usual, if you had any problems, okay, some people have finished the challenge, great. If you're having any troubles with the challenge, let us know, and we'll try to help you out and get you unstuck. Okay, so let's go ahead and finish out the lesson, and then we can move on to the next part of the stream. Okay, so we did Operation Orchid, and let's review the digital forensics concept we learned in this workshop. So SleuthKit, the SleuthKit software. The SleuthKit is a popular program used in digital disk forensics and includes several useful commands for interacting with disk images, including the MMLS command, which displays the media management of the disk image in a list format. So it basically lets you know where all the partitions are. We use the fstat command, which is used to display statistics associated with the file system. And what's next? So in the next Hacker Frogs After School Digital Forensics Workshop, we're going to use a different program to look at disk images in a more intuitive way. So we're going to use a program that was built on top of the SleuthKit, and it's called Autopsy, and it's a very popular program for disk image forensics. Okay, so this is the end of the Hacker Frogs After School portion of the stream. Let me go ahead and finish out the call with the students in Zoom, and we're going to come back and we're going to change topics on the live stream after that. So we're going to go over to the Be Right Back screen on YouTube and Twitch. We'll be back in a few minutes after I finish with the students on Zoom. So hang on.